Hello and welcome to another LangChain build video. Today we're going to be building a LangChain agent on top of Mistral and Nomic Embed Text v1.5. We're going to be using both of these through um, platforms that host those models instead of running them locally. Lance is making a video later this week doing some LangGraph work with local models, so stay tuned for that as well. And let's get started. I'm Eric from LangChain AI, and first let's dive into what some of the platforms and models that we're going to be using are. First and foremost, we're going to be using LangChain. LangChain is the best way to develop LLM applications. It's a framework that allows you to connect to language models, embedding models, and then kind of stitch them together into a functional application. We also offer some templates, which are kind of reference architectures for how to build things. So today we're going to be starting from a retrieval agent template and then modifying it in order to use a vector store instead of kind of a web-based retriever. The language model that we're going to be using in order to make decisions in our agent is Mistral. Mistral is a open source model. They have hosting built in through their Mistral AI platform as well, or you can host it on locally or through anything else. We're going to be using the Fireworks connector today. Fireworks has kind of an added bonus feature of JSON mode, which kind of enables forcing structured output from some of these models. Funnily enough, the template today actually doesn't start from JSON mode, but we can play with that a bit if we have time. The embedding model we're going to be using is the brand new Nomic Embed v1.5 model, which is going to be an open source model. It has a lot of cool features, such as using Matryoshka learning, which allows you to kind of choose the length of the embedding, the dimensionality of the embeddings that you actually produce. The Nomic announcement, which will be linked in the description, has kind of a cool write-up of how that works. And so we're going to be using that v1.5 model. For our vector store, we're going to be using Chroma, which we're just going to be using local persisted version of Chroma as a vector database. We'll be using Langsmith, which is LangChain's kind of first-party debugging and observability product in order to see what's actually going on in our agent and what tools are getting called. We're going to be using LangServe in order to host it. LangChain templates are all designed to be hosted as REST APIs. So LangServe is kind of a fast API extension that makes it really easy to host chains and play with them in a playground, which we'll be using a bunch. The initial template uses an archive retriever, which looks up academic paper summaries based on the query. So you'll see that for a little bit. And then we'll be using kind of community contributed Docusaurus loader in order to index a few pages of the LangChain Python docs in order to be able to ask questions about that. And with that, let's dive in. So the template we're going to start with, you can find on templates.langchain.com. That's where all of our templates are, and we'll search for our retrieval agent. We're going to be starting with the Fireworks one, which uses an open source model. The base one uses an Azure hosted OpenAI model instead. But today we're going to be focused on open source models. And we can use just the instructions that are in here. So first, let's install the LangChain CLI, which is we're going to use to kind of pull down that template. And to do that, I actually have the command already here. We're going to do a LangChain app new command in order to create a new application, and we're going to initialize it with the retrieval agent Fireworks package. We'll actually skip installing them with pip, and we'll use Poetry instead. And it spits out this helpful message, which gives us some code that we'll want to add to our app/server.py file, where we're supposed to add our routes. And we can even put our import at the top to make VS Code a little bit happier with us. I can make that a little bit smaller. So here we're just going to import our default retrieval agent and we're going to add that at our retrieval agent fireworks route here. Then we're going to run it. First, we need to do a poetry install in order to install our dependencies. The CLI has helpfully added the package to our PyProject toml so poetry knows where to find it. And then we can do a poetry run LangChain serve in order to access that playground. So it's going to, oh, and it looks like I didn't save my server file. So if I save it, it'll hopefully reload that, and it works better now. And we can see that we have a little playground link here for the path, and that's going to be at localhost 8000 retrieval agent fireworks playground. And so to start, let's ask it a question about something that it's going to want to use the archive tool for, which can be what is Matryoshka learning. And it looks like it's looking up Matryoshka learning in archive, and we can actually follow this progress in LangSmith, where hopefully it's going to look that up. It looks like it's wasn't successful at actually pulling something out because the two archive searches for Matryoshka learning had some summaries that were not particularly helpful at describing what it is, but that's okay. Here it retrieved a PhD thesis as well, which is probably a little bit in the weeds for Mistral to be able to synthesize what Matryoshka learning is. But that is all good, and we'll kind of go through the code and see how we can swap out this archive retriever for one over some of our own documents instead in a second, which is kind of the end goal of today. So to do that, let's start by ingesting some documents. So today we're going to be using our Chroma connector. This is a LangChain community vector store, and so we can import it as such down here. We're going to be persisting it to disk just so we can have kind of a separate ingestion script, which is going to kind of download all the documents and put them in there, as well as kind of connect to it in our agent through a retrieval tool. And then we're also going to be using our nomic embeddings, which will allow us to use that 1.5 text model. In the docs, we use the V1 model because the 1.5 model is coming out with the release of this video tomorrow. And that should all be good. So let's actually create a ingestion script. We'll call it ingest.py, and we'll put it in just the root of our project. And we can first import our nomic embeddings and Chroma. So we'll import LangChain community vector stores. We'll import Chroma, and from LangChain nomic, import nomic embeddings. And we'll need to add some dependencies for the nomic one. Chroma will already be available because the template we had LangChain as a dependency. And here we'll want to poetry add LangChain nomic in order to get access to that package as well. And we'll first instantiate our embeddings, where we'll just want that to be based on our nomic embed text v1.5 model. And we'll have Chroma as, we'll call this our vector store, as a embedding function of embeddings. And we'll want to set a persist dir or directory of ./ChromaDB. So we can do that there. And then we will ingest some documents. And actually, while we're here, let's actually just skip doing some of these test documents, and let's jump straight into using the Docusaurus loader to kind of populate that with some section of the LangChain docs. So to do that, we can look up our Docusaurus loader. In the LangChain docs, we're going to need two more dependencies for this. At ingestion time, we're actually not going to need this. At ingestion time, we're going to need Beautiful Soup and LXML in order to load those, load the sitemap as well as the documentation pages in there. We won't actually need those at runtime for our app, so we don't need to add them as explicit dependencies. So instead of Poetry adding, we can just Poetry run pip install of those two, just so I can access them locally. You can achieve the exact same thing by adding kind of optional groups as well. So you can have like an ingestion group in your Poetry file, but either works. And then we will start to use that document loader. We can skip this nest async IO step since we're not doing this in a Jupyter notebook. We're doing this in an actual Python script. And this is kind of how we configure our loader. We're just going to index one section of our docs. If you do this yourself, please do not always run this against the entire docs. We have a lot of docs in our doc site, and so Vercel, who hosts our docs, will block your IP address and not let you access it anymore. That has actually happened to our office a few times from running this. So we are going to filter the sitemap URL with this down here. By default, this does not get the pages that we want. This is just going to get the kind of sitemap loader. We can actually instead just do everything under the expression language, which will get kind of all of these pages about the expression language, so we can ask some questions about the runnable interface and that kind of thing. So that's going to get our documents. Next, we're going to want to split those documents a little bit. Some of those pages are too long for the Nomic embedding model, which has an 8,192 token limit. So let's do some text splitting, where actually I think that's in here, retrieval text splitters. And we're just going to use kind of the main recommended one, which is a recursive character text splitter, which we can do from LangChain text splitter, import recursive character text splitter. And that we can configure with a chunk size and a chunk overlap. And I can actually just use this. We don't need to define those two. And since we have an 8,000 token limit, let's just do 2,000 token there, and then we can have kind of, or this is characters actually. So 2,000 character chunk size with about 100 characters of overlap should work fine there. And then we'll want to kind of split documents from that. So we can do text splitter dot split documents of documents, and we can call that chunk docs. And then we're going to want to call vector store dot add documents of chunked docs. And we can try this. So poetry run python ingest.py. And hopefully this will create a chroma underscore db folder in here, which is going to persist all those. It's complaining that it couldn't import the ChromaDB package because we haven't added it. So that was the step I forgot. So we can poetry add ChromaDB in order to address that. And then we can try again to run ingestion, and hopefully this will fetch those pages. So it looks like it's fetching 29 pages, and then adding those documents at the end. So far, so good. One thing to mention is I do have a Nomic API key set in my environment. You will have to get one of those yourself if you use the hosted Nomic embeddings. Obviously, if you use one of our other like local integrations or something like that for your embeddings function, you will not need that. But if you follow along in the Nomic docs, it'll walk you through that. So with that, let's actually go and switch up our package a bit in order to give our agent the ability to search our documentation. So instead of this archive tool, we are going to want a retrieval tool based on our kind of Chroma connection. So we're going to first want to connect to our vector store, and we can actually use the exact same code that we have up here in there, except we won't need the docusource loader or the text splitter since we're not ingesting any documents here. And we can move those imports to the top. So that's our embeddings in our vector store. We can create our vector store retriever, which is going to be vector store.as retriever. And then we can create our vector store tool, which Copilot is nicely formatting for me. Let's call this our doc store tool, and let's make a little bit prettier of a description. Vector store tool description. Let's call this a tool that looks up documentation about the LangChain expression language. Use this tool to look anything up about also the runnable interface, or that should be good, or the runnable interface. And then we can pass that in as our description there. So that's our vector store tool. And then instead of our archive tool, we'll pass in our vector store tool here. And we can even delete our archive tool up here if we want to. And that should just connect our agent back to our vector store. So we've given it another retrieval tool. Let's try running that and see if we get any errors. Note that an important part here was that our persist directory was set the same as we set it in our ingestion script, because otherwise it would connect to kind of an empty ChromaDB. So far, so good. So let's go back to our playground, and then we can ask what is a runnable pass-through. I probably didn't need to include the parentheses there. So it's looking up documentation for that because it's a runnable. So Mixtral did a good job there. Let's actually try opening this in Langsmith instead. And it allows passing data through the chain without any modifications. So that was the kind of final output. We can see which chunks of documents it actually retrieved here. And it looks like it got some sidebar. I actually don't even see a runnable pass-through mentioned in that one, and mostly sidebar. So it may have hallucinated that. Let's actually try without the parentheses and see if it grabs anything different. So we can look at this run, and this time it actually tried looking it up twice. it got our kind of runnable pass-through page about passing data through, which is good. And on the second one, it searched for binding runtime args, which got something else and was able to produce the final output, which was actually pretty similar there. But it's producing some references while producing that final answer, which I feel pretty good about. So we have tested that. And this was actually on our Docusaurus docs. So we had a lightning quick build video today. Let's try some other things. Let's ask about runnable. How do I pipe the output of one runnable into another in LCell? And let's see if it's able to get a relevant document there. So here, the first time it calls the tool, we're getting some sidebar again. This is kind of going to show how important setting up your ingestion is. So if a kind of future exercise we could do would be to clean up some of the documents we actually ingest to make sure the relevance is very high. And here we're talking about kind of what LCell is good at. And then here is kind of an overview again. And then here we're searching for passing data between runnables and LCell, which got all sidebar again. So here, I think these are probably more shortcomings in how I was loading the documents. And in a future video, we can do some fancier ingestion strategies on these. But here, here was the output of the piping the output of one runnable to another. And this one actually seemed to answer more about runnable pass-throughs and the intermediate content before producing final answer. And it's saying that we're supposed to use a runnable pass-through because our documentation returned more stuff about runnable pass-through than runnable sequence, which is a little bit too bad. But as you can see, definitely some prompt engineering and document cleaning to be done when setting up one of these systems, especially when using open source models. And yeah, we can do some work to improve that in a future video. And things I just want to kind of emphasize here is this is using a pretty cool just React construct in order to produce the JSON blob. If we look at the code, we can actually see that this is being pulled from Harrison's hub. So we can actually look up that prompt and kind of see how that's being formatted. And what this is doing is it's basically kind of priming the Mixtral model in order to produce valid JSON with relatively high probability. So even without JSON mode, this Mixtral model is able to produce good agent tool calls without much like custom prompt engineering aside from using Harrison's prompt here. And then, of course, we're using our Nomic embeds v1.5 in order to actually retrieve things from the documentation, and our ChromaDB to host all of that. Thanks for tuning in.